Draw it. Yeah. Ooh. Welcome to CHADEV, everybody. Welcome back. Yeah, go ahead. Give that up. Give that up. Let's get this going. I like that. I like that. A little bit of energy in here. Sometimes it can be a bit sleepy. I don't care for that. All right. Let's see. Let's just go ahead and get this out of the way. Next week, we have one Mr. Bruce Tate coming to be with us. Yeah, go ahead. Give it up for Bruce Tate. Yeah, you should be excited. So Bruce is going to be coming all the way from Austin, Texas to be with us. If you don't know him, he's a pretty prolific published author. He's got over 10 titles to his name. He's been pretty big in the Ruby community and written a bunch of books on Java and that kind of stuff. Shifted his focus over to the functional world, and he's going to be coming to give us a talk about the first in the series is a two-part series on changing technical landscape. Want to give a shout out to Chris Keithley back here, who made that connection. Yeah, Chris, thank you. Appreciate that. He's been out on the speaking circuit and kind of made that connection, and Bruce and I were able to have beers and work something out a few weeks ago. Longer than that now. Anyway, so we're excited to see him come in and give that talk, and then spread the word. Spread the word on that. There's going to be a little something for everybody there, whether you're in the startup world or the enterprise world or what have you. So we want to make sure that it's a good, warm welcome for him. And he'll be returning probably in a month or so to give the second half of that series. So real excited about it. I think Andrew, you've got an announcement, right? Everybody give it up for Andrew.
Hey there. So I had a couple of things I wanted to cover. So one, I already pitched this once, but I'm going to probably do this ad infinitum until everyone's tired of hearing it. So February 15th, reverse pitch here, collaboration between CHADEV and Colab. And we have now 3 pitches that will each have dedicated funding associated with them. At least one of which is a web app, so that's a little bit more interesting, I think, to a broader audience. The other are a little more very sector-specific technologies. But anyway, love to have you out for that. That information will be going out via the CHADEV Meetup Group email blast soon. And then the other thing that we have Kate here from Metro Ideas Project, and Metro Ideas has been engaged by the Enterprise Center, the organization I work for, to study some of the metrics of how we measure the success of our innovation district. So we're going to let Kate talk a little bit about that. I think she may want to speak to some of you if you have feedback or information, but I'll let Kate explain all that.
Hi. So bear with me, this is my second week in Chattanooga, so I'm kind of getting to meet everybody. I just moved here from New Orleans, and I am now working as the research director over at MIP. What we're trying to do is sort of do a general assessment of the innovation district and sort of understand the successes and any potential issues or kind of ways to improve it, but also kind of looking at the spillover effects to the other neighborhoods and parts of the city. One of the things that I'm trying to do is conduct one-on-one interviews or focus groups, if you prefer, with people that actually work in the innovation district and live, if possible, but especially work. And so I wanted to come today, since so many of you do work in the innovation district, and kind of work directly with that, and see if anybody's interested in setting up an interview with me. Maybe 30 minutes over coffee to kind of chat about your experiences working here and working in this kind of field and in this specific kind of organization of the district. I will be here after today's meeting if you want to stop by, and I will also be sending out kind of as many email blasts and stuff through different networks that I can. So if you see one, please feel free to contact me. I will take you out for coffee and we can, yeah. Oh, okay, sorry. We're basically, to summarize, an urban policy research think tank, basically. We work with foundations as well as cities doing different kind of urban policy research. So we've done education projects, and we're looking to move kind of into broader kind of neighborhood assessments and kind of building metrics to sort of understand what's happening here in Chattanooga, but then also expanding to other cities across the US. Hopefully that summarized that. All right, thank you guys so much.
Thank you, and without further ado, Micah Hausler.
Hey everybody. So I'm really excited to give this talk. I kind of wanted to give it for a while. I've talked earlier last year about Mesos and as kind of another clustering tool. But Kubernetes has been, for us at Skuid, something that's been really awesome in kind of transforming how we do infrastructure. So this talk is really just kind of going to be an introduction to Kubernetes. There's a lot I could talk about. I could probably stand here for 3 hours. But this is, I want to kind of give you the basics of what Kubernetes is, how you can use it, and kind of why it really excels. So first, I kind of want to talk about architecture. I'm an architecture geek, and so this kind of jazzes me up, but I won't spend a super long amount of time on this because I think while this is really cool, the kind of the power of Kubernetes is not just in the architecture, but in the API and the user experience. So like most other cluster management systems, whether you're using Nomad, if you're using Nomad, I'd like to hear about it, but Mesos, anything else like that, you have a master and worker set up. In Kubernetes, you can have multiple masters for hot failover, redundancy, but you can get by with just one. Your workloads will still work if the master's down, you just won't be able to schedule new ones. And kind of delving into that, the architecture for the master, it uses etcd as its key value store for storing most of its state, its state data. So if your masters were to go down and your etcd cluster was still online, as soon as your masters come back up, they pick right back up where it left off. Don't lose your etcd cluster. And also digging into the master, there's 3 major components to it. There's the API server, there's a scheduler, and there's a controller manager. These are 3 separate processes. The API server is kind of what everything talks to, what you as an administrator talk to, what your worker processes, which we'll get to in a minute, talk to, and actually what the scheduler and controller manager talk to as well. The scheduler, what that does is it's in charge of scheduling workloads. So if you have, get into some of the terminology, but a workload that you want to run 1 copy of or n copies of, this will assign that out to the particular nodes, and you can specify that, and we'll get into that in a minute. But that's responsible for scheduling. The controller manager manages state. So when you say, I have this node and I want it to stay online, and here's its health check script or endpoint, if it's a web application, the controller manager makes sure that it's healthy, it's online. If it's healthy, we'll kill and reschedule. Getting into the worker, the basic kind of high-level view of this is that the primary process for a Kubernetes worker is the kubelet. That gets directive from the master to say, okay, spawn this process, or terminate this process, or attach this volume, those kinds of things. It talks to Docker or Rocket if you're using Rocket, and runs your workloads in containers. The kube proxy is an additional process that manages networking for you. So I'll get into that in a minute because that's talking about architecture, its own thing. But for now, we'll just leave it at that manages some of the networking for you. By the way, if you have questions like throughout this talk, just like pop up because I kind of want to like be able to answer those if this isn't clear. Some terminology. So I've been talking about workloads. The basic unit of work in Kubernetes is a pod. A pod is one or more containers that you have defined and said run with these environment variables, these arguments, open these ports, like very standard if you used Docker. It's very similar, practically identical. The configuration names are slightly different, but they're all there. And this is the text representation for a pod if you were to represent it as a file. If you submitted this file to Kubernetes and said run, it would create you a container running the image alpine tag latest at the command sleep for 60 seconds. And there's a lot of other parameters, but one of those parameters is pull the image if it's not present, otherwise just keep it. And restart policy never. So if this pod exits, don't restart it. Could be always, which means always restart every 60 seconds after it's done sleeping. And the name of it is Alpine, and the namespace is default. A service. So in this previous example, you see that metadata parameter. Every Kubernetes object has a metadata parameter on it, or parameters, and a label field. This pod example doesn't have any labels, but a service is not just an individual pod. A service says match all pods that have a certain label set. So here's an example of a service. We say we're going to name the service itself Nginx, and we're going to give the service its own label, Nginx. It's kind of superfluous, but it has a label. The spec is kind of the more interesting part. So we say selector, and that just says any pods that have the labels key app, value Nginx, route traffic to. So the ports that we want to do that on are, we call it HTTP. It's just an alias that we can reference. But the port that we want to hit on the back end is 80, but we want to serve it up as the service on port 8080. We could make it 80 and the back end 80 and the service port 80, but basically this is like a proxy. So if you're familiar with like running Docker on your local machine, if you run port 80 on your container and port 8080 on your machine, this is kind of that idea. One other type I want to talk about, there's a lot of types, I'm not going to get into them all, but just kind of want to hit the ones that you might work with the most, is a deployment. So before that pod that we looked at, if we scheduled that to our cluster and said run this, it would go onto some node somewhere, and if that node died, we would not get that pod. That pod would just be gone. There would be no other pod to replace it. If you use a deployment, it's basically a definition of here's how a set of pods should look, and make sure they're always online. So you can see in this, I named it deployment. It's called Nginx. It's in the default namespace. And then in the spec, you see replicas is 3. So I want 3 of this. And similar to a service, you have a selector there that says, I'm going to basically this deployment is going to manage anything that has the label app Nginx, the label pair. And so below that is the template for a pod. So we say metadata apply to all pods that we create from this deployment. The label is app Nginx. And below that we define, like we saw before, our pod, but template it out a little bit. So we see container name is going to be Nginx instead of Alpine. And it's the image Nginx, and we want to expose the web port. So when we submit this to a cluster, it will create 3 Nginx containers with the label app Nginx. With that previous service that we created, if we create both, anything that you point to the service will hit those backends because they match the label app Nginx. Does that make sense so far? Okay. And so one other type I want to talk about, because I think this is kind of differentiates Kubernetes from some other cluster managements, is config maps. So config map is kind of what it sounds like. It's a map of config values. Here's an example. Again, starting to look familiar. You see an API version, a kind, and metadata. And then you just see data. And in data, it's just a bunch of key value pairs. Redis.host, there's the value. Lunchtalk.conf, you see an Nginx configuration. You see server name, a listen directive and pass to a backend. With config maps, you separate your configuration from your application code. So I'll show in a minute, but basically you can inject these into your pods as these values as environment variables or as files. And all of a sudden your images, if you're used to using like Mesos or ECS and you have to, say you're using Nginx, you have to pack in your Nginx configuration into your image because there's no way to say, run this version of Nginx, but also use this configuration file. With a config map, you can say, here's my nginx.conf, mount it into my pod, and I'll show that in a second, under this, at this file path, and use the contents of this config map. So if you're used to having to say, take the Nginx base image, add your own config file to it, push it up to a registry, and then deploy that out, you can, if you're using Kubernetes, basically stop doing that. All you need is the default image, say if you're using Nginx, drop in your own config and you're good to go. Unless you need some additional, Nginx plugins or whatever, if you're doing something special, then you might need to do that. But for most cases, you can probably use the default image. So I hinted at this before, but I want to talk about networking. This is where I kind of geek out because it took me a little while to understand this, but once I got it, I was like, this makes so much sense. So in a typical setup for a cluster, clustering tool, say you're using Mesos or your own home run system using console or etcd, something like that. This is probably an image that you'd be like, okay, yeah, that kind of signifies my infrastructure a little bit. I've got my cluster management, or not cluster management, but service discovery at the top. I've got using console or Nginx or something, and I'm routing to some Docker backends on some ports that are randomized, and console knows, and I do a lookup in console and I get the DNS name for it. And the DNS name happens to be the node IP with a port of the workload. So if I wanted to talk to this bottom left container, I'd hit 127 or 172.31.01 port 3099, and I'd talk to that container. Whether I'm on a node or in my local cluster or on another container, that's the address I have to hit. Say I'm on box 2 and I want to hit that, I still have to hit that other node IP. Kubernetes is a little bit different. There's kind of 3 things going on here. Instead of just having a single address space, that 172 range, there's really 3 networks going on. Right here, I'm talking about 2. I'll talk about the third in a second. Kubernetes there's a couple different network plugins that you can use, but one is called Flannel. It's by CoreOS. The other is called Calico, and Calico uses BGP. BGP is Border Gateway Protocol. It's what the internet runs on. So the internet routers, when they configure routes, it's all dynamic. But when you have 2 networks that are on different ranges, Border Gateway Protocol allows these 2 networks to talk to each other. And so it's actually very similar in this way, but just on the data center level. So digging into that, every pod has its own IP address. Every node, and by node I mean VM, could be a metal machine, has its own IP address. That's where the kubelet runs. But every pod, every individual unit of work has its own IP address and is addressable from the entire cluster. So if I'm on the second box, the one on the right, and I want to talk to that Go container on the box on the left, I don't hit 172.31.01 some port. I hit the IP address of that pod, and I'm automatically routed to the right port, or I hit the right port. There's IP tables, kind of magic going on, or BGP, but that's how that works. So when you want, say, your Go app to talk to Redis, no matter what server it's on, it's going to hit that same IP address of the Redis pod. Is that making sense? It's kind of high level, but that's kind of how the pod and node networks work. So hinted at this, but there's a third network going on. So remember services that we talked about? and like talking about selectors and labels. So the service type, if we created a service called lunch, and we set the selector app as lunch, and the port we want is 3000. If I don't select a cluster IP, one will automatically be assigned to the service, and it will be on a different network range than the other two networks we were looking at. So there's a third network being overlaid on this. So any pod you're on or any node you're on, if you hit a service IP, it will properly route to the correct backend. So if I'm on node 2 on the right, and I hit the IP address 10.100.0.184, I will get routed to either the Go app on my node or the Go app on the other node. But I don't have to do any DNS caching. If you're doing the other setup where you have, go here, you're using console for DNS, for service discovery. And you accidentally start caching some of those results where, okay, my service is on those 4 workloads on those 4 port addresses, and one node goes away and you accidentally cached the wrong, an old workload, sorry, like you're not gonna get a response. If you're using a setup like this where you have a service IP address for the whole service, so anything matching the label app lunch, if you send a packet to that IP address, you will hit the correct destination. Even if the pod goes away, the route table will get updated behind or underneath you, and you won't have to worry about DNS cache invalidation. So that, to me, that's like, well, that's so awesome. And so going along with that, there's also an intra-cluster DNS. So if you want to look up a service on your cluster, say I want to talk to my lunch service or Redis. In this example, I did the lunch service, but you just do service name dot namespace dot service dot cluster dot local, and you hit that address or that domain name, and you will get your backend. Is that making sense? Cool. So that's kind of the architecture that I wanted to talk about, just to kind of give some common ground on this. Next, I think this is, I wanted to go through a demo because I think when you get to see something, it really makes a lot more sense. This for me anyway. All right, so what I've done is I have, there's a project called MiniCube, which runs Kubernetes on your laptop. It's kind of like Docker for Mac, Docker Compose, or Docker Machine, and very similar, but it runs a small VM on your laptop running the Kubernetes master processes and the worker process. So kind of going through the examples we talked through before, I'm going to show just a single pod. Can you all see that? Is that visible to everyone? So that actually, wow. Do this. That might be a better background. Is that easier to read? Okay. So what you can see is we specified an API version. The kind is a pod. The name is Alpine. It's in the default namespace. Namespaces are just groupings of resources. You can reference things in other namespaces, but it just kind of helps section out things. So you could have a prod, a test, dev namespace, or you could just have separate services that you want just operating independently in your cluster in different namespaces. So we say we're going to run one container. It's going to be Alpine, and we want it to sleep for 60 seconds. Don't restart. You know what? And rather than doing 60 seconds, let's make it a little bit shorter so we can actually see that stop. So all I have to do, I'm going to use the command line client for Kubernetes. It's kube control. There's a couple different ways to do this, but the apply command does kind of an upsert functionality on your config files. say -f1 pod. Okay. We get pods. We see we have a pod running now. It's 2 seconds old. We can kube control logs, follow, Alpine. And okay, it stopped. No more pods running. Nope. So that pod is now gone. If we want to look, there's also one other really handy feature of Kubernetes is it has a heads-up dashboard for admins. Cube dashboard. I don't usually use MiniCube. I usually actually work on a real cluster. So there. So we see our pod. That's our pod that died. We can look at its status. It succeeded because it exited with a 0 status, so it didn't fail. We can view logs if there were logs. Didn't log anything. Here's the IP address of that pod. And here's our namespaces. And we can see our other object types here. So we'll go back really quick. So moving on, okay, pods are great, but if they die, they might not restart. If the node goes away, it won't restart. What I have here is a deployment. This is just like we saw before, Nginx, we're just running one, and it's got the labels app Nginx, so we're going to create that. Pods, okay, we have Nginx running. No logs, nothing's hitting it. Since we haven't defined a service, we can't actually get to this pod yet. So what we need to do is create one. This is, like we saw before, a service. It hits node, it hits Nginx, and it allocates a port on the node, some random high port, or if we specify it, node port, that we can hit on that node to talk to this backend service. So let's create that. Okay, created that service. Get output YAML of that service. There it is. We have our service created. Nginx default. There's the node port. So if we run cube service Nginx, we'll automatically go to Nginx. Okay, so cool. All right, we're getting somewhere. We have a pod running. We were able to get to it. This is my VM's IP. If I wanted to get, well, okay, so remember we talked about 3 networks. There's the pod network, so if we go back to our dashboard and we look at pods again, we'll see Nginx is running. Its IP is here. If we look at our services, we'll see an IP for the Nginx service, and it's there. And our node itself is running on this IP here in my URL tab. So that kind of gives you a real world example of that. So let's build on this. We want to start monitoring stuff, right? It's great that we have stuff running, but if we have no insight into what's going on, that gets not good. So Kubernetes comes with built-in Prometheus metrics endpoints, and it has its own Prometheus service discovery utility, so you can actually figure out what's running in my cluster. We have in this directory, we have a config map, and that just looks like prometheus.config. It's got just a YAML file for Kubernetes configuration, so let's create that. We have a deployment. That's running Prometheus. It's running that version, that image with those arguments. We're mounting, so remember before I talked about volume mounting config maps? At the bottom here, we have a volume, and we say we're getting the config map prometheus.config, and on the container, we say this config volume sort of object we created down here, reference that, and mount everything from that config map into etc Prometheus. So that config.yaml that we created will get mounted in there. So let's go ahead and create that. Okay, and let's create there's a Prometheus node exporter service that just gives node like statistics if you want to monitor your actual nodes. And then we actually want to talk to Prometheus, right? Like, we can't get there because we don't have a service. So there's a service for Prometheus. So what it looks like, it just says service, anything that has the labels SVC, Prometheus HA, map to. So let's go Cube, service, Prometheus. And we have Prometheus up. So if we look at our targets, I kind of did some magic, but Prometheus can look up what are all my services that are running, and anything that has the annotation similar to a label, just for extra information. Prometheus scrape true, start scraping. So that node exporter, that service that we started, that had the Prometheus scrape label. So we're able to get metrics on that. So we can go to Prometheus and look up container memory RSS. So this is memory used by container. Scale that down. So in the last 5 minutes, that's all our containers that are using memory. We can pare this down. You can watch the Prometheus talk if you want to learn more about Prometheus, but it's awesome. Okay, so let's leave that running. So let's look at another service. In this, so I've created kind of a demo app. It's on GitHub with all these examples as well. And I wrote it in Go. It's just a really dumb 3 endpoint service that has a welcome page, hello cha devs, a proxy where if you have a query parameter queue, it will go scrape that endpoint for you and return the HTML, and just an error page that's a dumb error. And it also, well, I'll get into that in a second. So if we look at that deployment, we call it the name is Lunch Talk. We match selector app Lunch Talk, create it with the label app Lunch Talk. There's the image that we want to use. That's the port we want to use. We have a liveness probe, so if Kubernetes hits slash metrics on port 3000 and it doesn't get back a 200 response, that's an unhealthy node, or an unhealthy pod. And after, I think the default's three bad hits to that endpoint, it will kill it. And that's all configurable. The timeouts and everything are configurable. You can see initial delay. We give it 10 seconds to actually start up. But yeah, so let's create that. So we now have Lunch Talk running. Look at the logs. Okay, we're listening on port 3000. All right, now we need a service for it again. This service says scrape Prometheus. This is an annotation similar to label, but it's not used for scheduling by Kubernetes. It's used for additional information for things like Prometheus or whatever else you want to do. We don't need that one just yet. So we set Prometheus scrape true. Prometheus use this port. The namespace is default. Selector app Lunch Talk. The target port, the backend port of the pod is 3000, but proxy to port 80. So if you're in the cluster and you hit the service lunchtalk.default.service.cluster.local port 80, you will get a response, not port 3000, because that's the pod's port. So create that. Okay, so MiniCube service lunch talk, and okay, hello cha devs. All right, and if we want to go to that proxy, q equals skuid.com. Okay, give it a second. All right, there's our HTML for skuid.com. It went and did stuff. That's cool. If we go back to Prometheus and we do HTTP request integration, we'll see our app Lunch Talk. No, just for Prometheus. We have our metrics here, so let's go to metrics. We have a metrics page on here. Okay. So, oh, that's not what I wanted. Okay, request latency. There, we can now see the app is, the pod is lunch talk. Here's our latencies by, our buckets by path. Great, we got monitoring, okay. So we have a service, that's pretty cool. Like we went from having nothing running to having a small config file that pointed to a Docker image and we're able to serve stuff. So that's great, but oftentimes you don't want just one. So if we need to, say we wanted 3 replicas of that, we can just use the kube control command to scale that up. And now we have, it said we set replicas to 3, so get pods, we now have 3 running in our backend. So if I hit this endpoint, I'm gonna be getting back, you see these values are changing? It's a different node name that I'm talking to in the backend. So if we, yeah, that kind of gives you an idea. And now, sometimes, like, we might not want to just use the same image the whole time. So we can also update the image dynamically without having to change that whole config. So if we set image to latest, we now look at our deployment, and the image is no longer that git hash, but latest. And those pods are running. So let's look at 5. Do I do it there? No, okay. All right, so that's great. We're on MiniCube. That's cool that we're like, you know, creating stuff. But that's like on my laptop, right? Like that's not that cool. So what we're going to do is actually create something in the real world. So we have our own multiple clusters of Kubernetes at Skuid. And I kind of want to just demo, okay, that's great on your laptop, but like actually do something useful. Kubernetes, in addition to the stuff we've demoed here, has types for volumes. So, and it's cloud provider aware. So if you're using Google, Azure, or AWS, it will provision volumes for that cloud provider for you. So if you want an EBS volume attached to a pod, it will dynamically create that volume and attach it to a pod, and then if your pod goes away, reattach that to a new pod for you. Super cool stuff. And create load balancers. So we're in Amazon, so if we look at our service here, we added an annotation. Here's our SSL cert we want, here's our backend protocol, here's the port that we want. And we tell Kubernetes, or Prometheus not to scrape it. So let's create these resources. Big map. Oh. All right, we gotta not use MiniCube, we gotta talk to our real cluster. There. So I've created a demo namespace for this demo. I'm creating this config map. It says, here's a value, Redis host. Lunch, we put an nginx config in here. Have some nginx configuration. Created a Redis, I'm creating a Redis service with a and a pod or deployment. So if we look at that really quick, we were launching a Redis. That's the deployment. And then we have a service down here saying app Redis, map to Redis. One other type that's very similar to config map is called a secret in Kubernetes. And if we look at that really quick, here's a secret. Secrets are base 64 encoded. You put them in base 64 encoded, it decodes it for you, but it's obviously not encrypted, but it's a way that it uses to just sort of obscure it, so it's not just in the UI as plain text secrets. There's other backends you can have to, like using Vault to encrypt your secrets securely, but so this is just some random dev random data that's base 64 encoded. We inserted that into our secret. If we look at our Redis deployment, remember how I talked about using config map values for environment variables? Same thing for secrets. So in this environment, we set Redis password to the lunch talk, referencing the secret, lunchtalk.secret key password. And then when we run Redis with Redis server, require password, drop in the password from the environment variable. So Redis will start up with a password. So get pods, namespace demo, and we see we got Redis. Oh, no, that's not good. I did run this earlier today. Oh, didn't create the secret yet. That would be why. Okay, so delete this so it's easier than waiting for it to refresh. Pods, container creating. Access is probably on a different node, so it's got to pull down the image again. Okay, it's running. We got Redis running. Great. If we wanted to, we could Redis CLI into that, but I'll spare you all. So if we see that service that I showed before, not the Redis service, but the application service, this should auto-provision a load balancer for us. And I think the last thing was, okay, this deployment. So let's create this deployment. So that demo Go app that I showed you before, I also added to it a request counter. So on every request, we decorated our request handler with just a really dumb Redis client that increments a count on the key of the path for the request. So if you hit /home or /, it will increase a counter for /. If you hit error, it'll increase the counter for error. And in the handlers, we actually say, okay, what number request am I? Even if I'm not just on this pod itself, but on some other pod. So we just created that deployment. Demo. Okay, so we have 3 pending. Oh, 1's running, 2 are pending. We probably don't have enough memory on these servers because we scaled some things up. Yeah, insufficient CPU. Okay, so let's fix that. We allocated for this deployment, we need half a CPU, we said. Where is that? There. Request a quarter CPU allocated for this pod, but kill it if it goes over. Or cap, not kill it, but cap it at 1/2 CPU. So let's just wipe that line out, comment it out, recreate that. Again. Okay, so you see our old ones that were pending. Those will go away in a second because our deployment will rolling create our new ones, or the new containers. Okay, there we go. So that's this pod here. You see the deployment ID. That's our old deployment ID. This is our new deployment ID. Once that third one finishes creating, it'll delete the old pod. There we go. Okay, so we've got 3 now. If we inspect that service that we just created that said we should create a load balancer, okay, there's an external ID. Let's view that as YAML so we can see the full output. Okay, here's the host name of that load balancer. So this is a real load balancer. And if we, to make things a little bit easy on ourselves, let's go over to here and create actually, I have one already. Yeah, okay, this is my previous one. All right, save record set, go back to our host designs, make one for internal so it works here. There, set, okay. So I just created the record chadev.skuid.inc, and it's gonna go to this service. It wasn't there before. So if you guys wanna visit it, you're allowed to. And if we go to that, okay, we're not gonna get anywhere, but hold on. Okay, this is a funny problem. So give ourselves 50 seconds and then it will work. I hit the URI before, or the host name before it was actually propagated. So we'll go back to our demo really quick. Does anyone have any questions? Yes?
Can you describe the use of that?
Yeah. So before, yeah, okay, yeah. So the question was, can you talk about annotations? Like, how are they? I guess I'll insert. How are they different than labels? Labels are used by the scheduler to make scheduling decisions. If you don't have any rules, so rules meaning a deployment that does things based on labels, or a service that maps to certain labels, it might not do anything, but they still can make scheduling decisions based on those labels. Annotations are just purely informational, but other applications within your cluster or the kubelet itself knows about certain annotations and does certain actions based on them. So in the case of the ELB, the kubelet said, okay, I see this annotation, I know I need to go create an ELB. For Prometheus annotations, Prometheus scrapes every service you have and says, where the annotation set Prometheus scrape true, I'll scrape that service. Does that make sense? Yeah. So let's look at that again. Okay, now we're good. And hello, Cha devs. Okay, request counter 84. Some of you hit it already. Awesome. So if we go to proxy, we see the same thing for proxy, and Q equals, no, Q, I can type. .com. Redis nil, so that was the first one. But if I refresh, got one, and that's the second hit. Okay, cool. So that is two services talking to each other using like Kubernetes DNS to just find each other. Like, to me, that's magical. Like, that you just say, okay, create this resource, and there's automatically DNS name for it, and your services can talk to each other. So whether it's Postgres or Redis or whatever, that just worked. I'll show a little bit more detail on the deployment. So if we look at this deployment for that web app, we set the Redis host environment variable to be from that config map where that value was redis.demo, the namespace, .service.cluster.local, Redis password, inject that from the secret, and my application code, I don't know if y'all can see this, but says get the Redis host and Redis password and use that out of the environment variables. So that, and then we also, in this pod, all the other pods were just one container pods. This has Nginx in front of it, proxying to this Go application. So just so we can do some redirects or whatever as needed, enforcement of HTTPS, that kind of thing. But I just wanted to do this so you could see you can have multiple pods or multiple containers in the same pod. So go back to the slide. Here we go. What? Okay. Oh, I must have a transition that I didn't know about. So that's not working. Okay, so links, go to Kubernetes, check it out, play with it, download MiniCube, play with it locally. But it's super easy to get up and running a cluster, whether you're in AWS or in Google Cloud or Azure. It's really, they made it really simple to spin these things up. And there's the link to the GitHub. I'll post these slides, I'll put the link on that GitHub, but all these demos are on that GitHub. So if you run up MiniCube, you can create all these and play with them, modify them just to see how it works. So with that, thanks. Thanks for Skuid for sending me here on a launch day. We have a product launch today. So, but yeah, thanks guys.
I think we have time for one question. Quick one.
I went too long, I'm sorry.
Buddy? No? Yeah, okay.
Can I use config maps or secrets across namespaces?
I don't believe so. You can reference other services that are in other namespaces via DNS and hit them. Actually, even this is something I didn't even talk about, but you can actually firewall off your namespaces and even all the workloads in them. So this namespace can't talk to this namespace, that kind of thing. But no. Yeah.
Thanks, Micah. Give it one more time for Mike.
If you have other questions, talk to me.
So I will be sending out the announcement for next week's speaker, Bruce Tate. Pass that around to all your friends. We want to get the word out. We want to try to set a CHA-dev attendance record. I think that's like 91, and I think we can do it. So we had 50 here today. So let's just double that and set a record for Bruce.